So I want to show you guys some examples of how to create functions in C++. I have this main function here that returns an integer data. If you pay attention here, the return type for this function is integer. If I just say cout pi and I run it, if I go to my output, you can see I'm getting high here. I have a main function that the return type is integer. If I want to define another function, I can go here on top of the main and I say int my function and I say return 0. I defined a function which the name of the function is my function and it returns 0. If I want to call this function, I say my function open close parenthesis. If I run this program and I look at the output, you can see I'm not getting any output. So if I store the result of this function inside int x, and I say cout x, and I run my program, you can see in the output I'm getting 0. I created a function that the return type is integer. I'm calling it, and I'm displaying the result. Now I want to show you guys another example. Like if I want to create another function, I can create a function named add, which it takes x and y. It returns x plus y. If I want to call this function, I can say add 10, 20, and I can store the result in the result, and I can display the result. If I run this program, and if I go to my output, I'm getting 30. I have defined a function that takes two integers. It adds those two integers together. It returns the result of addition. Now I can create other functions, like, for example, I can create another functions in sub. And I can pass x and y. I can say return x minus y. I can create another functions mul, which takes x and y. And I can return x times y. I can define another functions, for example, div, which it takes x and y, and it returns x divided by y. I defined several functions here. If I want to call my first function, I can just say the result is add 10, 20. If I want to use my second function, I can say result equal to sub 10, 20. And then I can display the result again. Or I can say result equal to mul 10, 20. and I can display the result. Or I can say result equal to divide 10, 20, and I can see out result. So after each one, I'm putting an end L to go to the new line. And I run it. I'm getting 30 minus 10, 200. So in these examples, I created some functions. I'm passing data to it. This passing is called pass by value. If you pay attention here, when I call this add function, I'm passing 10 and 20. The value of 10 will get copied inside this x. The value of 20 gets copied into the y. This function returns x plus y. When you say sub, the value of 10 gets copied inside x. The value of y gets copied into the y. It returns x minus y. We could have functions that the return type is void. For example, I can say void. So I created a function that the return type is void. When the function runs, it displays hi. If I want to call the void function, I can just put the name of the function, open close parentheses. If I run this program, if you look at my output, it displays hi. So when you define a variable, sometimes you define a variable. For example, if I say int x equal to 100, I have defined an integer variable x, which is 100. If I say cout x, and if I run it, it will display 100. So in this example, I defined the variable. If I change the x and I say x is equal to 300, and I say cout x, and I run it, you can see the variable becomes 300. So when you have a variable, it means it can change. Sometimes you want to define a reference variable. For example, I say int ampersand t equal to x, and I say cout t. If I run this program and I look at the output, it displays 300. In this example, I'm defining a reference variable. This ampersand means reference variable, which the name of this reference variable is t. And when I say equal to x, it means x is going into t. It means t and x are both the same variable with different names. We can say the reference variables are like nicknames. It means they're names, different names for the same variable. Now, if I, for example, if I change the t and I say t equal to 0, and I say cout t, I get 0. If I say cout x and I run it, I get also 0. It means that t and x, both of them, they are referencing to the same variable, and both of them are 0. So in this example, I created a variable x. I create a reference variable t. I'm initializing my reference variable t with x. When I display t and x, both of them, they get 0. So I want to create a function that uses pass by reference. In my program, I will change this x to ampersand x and this y to ampersand y. Now this function is taking two different parameters, and both of them are passed by reference. When I want to call this add, I can just say add 10 and 20. But before I do that, I define two different variables. W is equal to 1 and t is equal to 9. Rather than 10 and 20, I put W and I put t. I'm defining this function, I'm passing there, and then I say cout result. If I run this program and I look at my output, it's displaying 10. I'm passing 1 and 9 to the function. My function is adding them together. The result is being returned, which is 10. So in this example, I'm passing them by reference. It means I have two different variables, W and T. We say W and T are local to main function. When I pass them, I'm passing W and T to add function. Inside the add function, X will get the value of W and Y will get the value of T. I'm adding X and Y, which will be actually W plus T, and I'm displaying it. When I run this program, I get 10. We say this is passed by reference because I'm passing these two to a reference variable. Now, if I change this value of X here, if I say X equal to 0, and for some reason I put my cout statement, I put double left arrow, I say W is equal to W and I display the result. If I run my program and I look at my output, W is 0 and then the result is 9. If I go back to my code, the W was initially 1. When I call the function and the function, I make the X 0. I return X plus Y, but since I'm changing the X, the value of the W changes to 0, which this means this function is using pass by reference. It means any changes to W and T will happen here also. Any changes that the function does to these two, X and Y, inside the function will affect the WT and in the main function. This is called pass by reference because we have reference variables. So if I take this one out, if I take this ampersand out and this ampersand out, and if I run it again, if I look at my output, result is 1, W is 1, and result is 9. It means even though I'm changing the X inside my add function, It's not changing the value of W inside my main function. This is called pass by value. If you have ampersand here, that is called pass by reference. I want to discuss difference between local variables and global variables. In this example, W and T, they are local variables inside the main function. It means the scope of these variables is definition of these variables until end of the main function. If you create global variables, you will define them, for example, at top of your program, G equal to 100. When you define a global variable, the scope of a global variable is all of the program. It means inside my main function here, if I say cout, G is equal to G, and if I run my program, you can see that I get G equal to 100 because G is a global variable. It's not a good practice to use global variables. Try to not create and use global variables. Try to use and create local variables as much as possible. If you look at this add function, x and y, they are local variables to the add function. This x and y, they are local variables to the sub function. So it's a good practice to use local variables. Try not to use global variables. I discussed function overloading. Overloading means when you have functions with the same name but with different signatures. I want to show you guys an example of overloading a function. For example, I can define a function add that takes x and it takes y. I can return x plus y. I can define another function add that takes x and it takes y and it takes z. It returns x plus y plus z. I can define a function which is an add. It takes double and it takes two doubles. It returns a t plus u. I can define another double function add that takes double w and double t and double I. It returns w plus t plus I. So in this example, I'm overloading add function. The question is, why should I overload a function? When you overload a function, you're making it more flexible. It means this add function, it can take two integers, it can take three integers, it can take two doubles. It can take three doubles. Let's see how we can use this function. If I have x, which is 1, and I have y, which is 2, if I say c equal to add x and y, and I say cout c, I'm getting 3. X is 1, y is 2, add x and y will add 1 and 2, it gets 3 and it displays it. So if I have 3 different integers, I can define another integer like z equal to 90. I can say add x, y, and z. If I run this program and I go to my output, I get 93. 9 plus 2 plus 1 is 93. Now, if I have 2 different doubles, if I have double y equal to 2.1 and t equal to 3.4, if I say add, let's name this one O. If I say add O and T, and I say cout C, if I change this int to double and I run it, I get 5.5. It means I'm adding 3.4 and 2.1 and I'm getting 5.5. This is the concept of overloading a function.